Okay, so we're trying to figure out something is linear versus nonlinear. Okay, so linear functions create a straight line. This is the last time you're going to hear me use the phrase straight line. Okay, and the reason being is that all lines are straight. If it's not straight, then it's not a line. It could be a curve or a turn or a bend, but it's not a line. Okay. So linear functions create a straight line when graphed. Nonlinear functions will not create a straight line. When graphed. So let's look at each graph and identify the linear and non-linear functions. This top left one, is it linear? Yeah, forms a line. Linear. That's what linear means. It means of a line. Okay. Go. We can go and top off the. Okay. This second one, is this linear? Here, yes or no. Okay, I can see why for both. So if you said yes, it's like, okay, these are definitely line segments, clearly. If you said no, it's like not all the points form a straight line. In this case, this is non-linear. Okay, all of the points must form a line. All of the points must form a line. In this case, while there are parts that if we're just to isolate that part, it would look linear, the entirety is not a line. Okay. Go ahead and work on these next 6 on your own. These next 6 on your own. I think they're going to be pretty straightforward. So it's linear or non-linear. Okay. This third one, linear or non-linear? This next one? Yeah, linear, non-linear, linear, non-linear. Okay. So from a graph, I think it's pretty straightforward. Let's take a look at this next section. A table for linear functions will show a consistent rate of change. Remember, rate of change, that's another word for what? Slope. Another word for slope. Nonlinear functions will not have a consistent rate of change. The y value or the x value? So that's the trick. It's got to be kind of both. Okay? Because if our x value remains a constant, then our y value also needs to remain constant. Let's take a look at this first one, for example. All right. So our x values keep going up by 1, right? Plus 1, plus 1, plus 1, plus 1, plus 1. So our x values are changing at a constant rate. Let's see what our y values are. Let's see. Plus 4, plus 4, plus 4, plus 4, plus 4. Are our y values changing at a constant rate as well? Yes. Okay. So if x is changing at a constant rate and y is changing at a constant rate, we know this is linear. Okay. What we've basically done is realize that the slope is remaining the same between all of the points. Okay. Let's take a look at this one. Is this changing at a consistent rate? So yeah, so plus 3, plus 5, plus 7, plus 9, okay? So there's a pattern, but it's not remaining the same, okay? It's ramping up. In fact, if we were to kind of graph this, it would look like that, the curve upwards. Okay, so this one is non-linear. Non-linear. Okay. This next one is x changing at a constant rate. Let's see. Yeah, I think all of them are +1, right? This one's -3, -1, +1, +3, +5. Yeah, this one is non-linear. Okay. If x is changing at a constant rate, y also needs to change at a constant rate. Okay. You guys want to do one more together, or are you good to do the next 5 on your own? Oh, sorry. Go ahead and do the next 5 on your own then, if you haven't done it already.
We only have 10 minutes left.
Mm-hmm. Time flies when you're having fun.
I go sleep in.
You get sleep in every other day.
No, but not a very morning.
Sorry.
Yeah,
Because I'm not a morning person, so they make me wake up when I have to, like, they let me sleep in like an hour.
yeah, they don't let me either because they know that if I sleep in, then I won't wake up.
Then I won't get up on the next app.
No, I won't get up really late, and then I won't do my work until then it'll be all late, and I won't have time to do it.
Yeah.
Wow, it sounds like your parents will have your best interest in mind.
No, it's not like they're strict, it's just like,
No, because they know I'm not a morning person, so if I get used to sleeping in like on at Mondays, then I won't get up for the next
yeah,
day.
so they know that I can't get up on Tuesdays.
Yeah.
Cool. So number 4, linear or non-linear? Linear. Yep. X is going up by 1, y is going up by 6. All right. Oh, you think so? You're not confident?
Yeah.
No, yes, no, yes. Well, you should be. No, yes. No, yes. All right. Non-linear, linear, non-linear,
What are
linear.
we doing now?
Flip it over.
We don't
All right.
have time.
All right. An equation for a linear function will not contain the following. Why don't we go ahead and underline not? Okay. Will not contain the following. Okay. Variables with an exponent greater than 1 or other than 1. Variables with an exponent other than 1. Variables being multiplied together. Variables being multiplied together. Okay. Variables inside an absolute value sign or under a radical sign. Those are like square roots. Those are called radicals. So square root, cube root, those are all radicals. Radical. Variables in the denominator. Of a fraction, unless the numerator is also there. Sorry, unless the numerator is also a variable, and there are no other variables in the problem. Generally, we're just not going to see a variable in the denominator. Okay. And variables cannot be used as an exponent. No. Let's work through these first few. Is this first one Is this first one linear? Boys. Is 2 to the power of x, is this linear? No, we cannot use a variable as an exponent, non-linear. 2x minus 5. Yes, linear. 1/2 x. Yes, we can have a fraction. Really, this should kind of read more like 1/2 x. Okay, this is linear. What about 5 over x?
Yes, it's a fraction.
No, we cannot have a variable in the denominator.
Oh, yeah.
Okay. Go ahead and work on these next few on your own.